Okay, I think we're going to start this. What? Is my mic on? Okay, so.
Oh, yeah, we're going to job description.
Okay, so for everyone in the room and everyone remotely, is the camera recording Vlad? Is that the blinking light on it? Okay, so Vlad's going to operate the camera, I guess. Okay, so for anyone who wants to follow along electronically or wants to see these slides later, does everyone know where Whistler is? HTTP Whistler internally, okay? There's this thing called 2018 V1 mod, a chop talk about V1 backup product. So that's what we're in. We're just gonna put that thing again for fun. Okay, so this is a talk that I've done a couple of times, and when we have new employees, kind of give you the bigger picture of what's going on in our company and how everything works, and then you can ask questions. But mostly this is about 5 minutes on our company and what we do here, and then we go a little deeper on what we call B1, the personal backup product. What usually follows is AB has also done a talk on what all the servers do and the B2 product line after this. But this is mostly about the company, overall, just to give you context of what we do here. Okay, and you saw that these slides are all available on Whistler right at the homepage and stuff if you want to follow along. And there's a couple of handouts, but they're not much better. Okay, so how the client works? Oh, I guess that's the name of the talk. Okay, so first of all, some context. What does Backblaze do? Okay, so this is a chart that we created when we were actually trying to raise funding, and this is a chart that shows our whole company history. It starts over at 2007, which was a very lean year because I was here all alone, and we didn't have a product, we didn't have any pricing, we weren't selling anything. So in 2008, I think, was our first revenue, which is absolutely hilarious. One of our first people who ever bought the product is a guy named Brian Beach. He now is one of our most senior engineers, but he actually was external to the company. He's a friend of ours, and he actually put his credit card on, was the first person. Tim Newfire, who's also a partner, claims that he was the first person because he used his credit card to test the billing system. But Brian Beach was the first external customer, which I thought was fantastic. And then, we moved around a little. So, and then if you can see, this is the total amount of storage in our data center. And the pictures on the walls around here, if you haven't been to the data center, this is what the data center actually looks like. These are real life Backblaze employees in these pictures. And when we say this is the amount of storage in our data center, and we're now, we're well past 600. I don't know what the current number is, but we're on track to hit an exabyte in 2018. And this is stunning to everybody. This is really stunning to me because when I started, it was like we were thinking about, maybe we'll store 4 terabytes or something, like we'll just do backups for friends or something. So anyway, we made 22.4 million in annual sales in 2017 alone. And in 2018, that's going to grow by 50%. We're going to cross over 30 million. And this whole thing is sort of growing faster and faster, growing 50% a year. In amount of storage is even faster than that. The number of employees, we're trying to grow by about 50% a year. So things are changing around here. We just want to, for new employees, want to give this talk. Okay, so we have 3 sort of product lines that we think of at this company, and this talk is mostly about the personal backup. The very first product we ever did was the B1 personal backup product. We don't call it B1 externally, but I think we should. The second product line is definitely B2 externally, but B1 is a very specific application. It's unlimited storage for $5 a month per laptop with a 30-day rollback history. It's a very specific product. We went to market with that product. This still results in, I'll show a slide a little bit longer, but it still results in the majority of the money we make at Backblaze. There is, it's funny, it says no sharing in the slide. We've just added a share file feature in B1 since this slide was made. B2 is totally different than personal backup. It's stored on the same red pods that you can see in the photos around here, but B2 is you pay per byte, and we're completely agnostic as to what you store. With the personal backup product, we don't like to back up your OS because you can get that from the original manufacturer. But we, you know, and stuff like that. We don't care what you store in B2 because we just bill you per byte. It's a completely, B2 is a much more, it's just an honest product. You know, there's a lot less worrying about averages and things like that. With B1, we really worry about what our average is. So, and just a history about why we price it $5 a month unlimited. It wasn't to attract gigantic users. It was because our relatives, my parents, people that are computer novices don't know what a byte or a terabyte is or a petabyte. They just don't know. So we wanted to remove sales friction. We wanted it to be just a no-brainer. So we priced it as $5 a month. Not, and they would say, well, what if I have an external driver? What if I add a photo? We didn't want to stress them out. We didn't want them to worry about prices going up over time or us trying to down or something. So it's $5 a month and it's unlimited. But that's not to attract big users, it's to make the pricing easy on people. B2 is for professionals. It's for people who understand what a byte or a terabyte is. It's for anyone who really understands it. It's for big servers. It's for anything you want to use storage for. You have any policy you want on it. You can decide as a programmer, you know, what your policy is, or maybe your tool that you use, a third-party tool. But the B1 was the original product, and we introduced B2 in maybe, was that 2015? Around 2015?
Yeah, and September.
Okay, and then we also like to think of a third product line, which is business groups. Now, business groups is a way of paying for other people's use of B1 and B2. The businesses had a very specific problem. They didn't want to put an individual credit card down on, for instance, 1,000 desktops in their organization and get 1,000 expensed, you know, bills for. So business groups allow one admin to pay for 1,000 licenses, and it pays for both B1 and B2. It's B1 and B2 appear inside your account that you created, the one true account that you created Backblaze. And business groups is actually a free feature. A lot of companies, when they say the word business, that means they charge more for it, or something like that. For us, it's absolutely free. Anyone can create a group, and we call it business groups because the most common group of people that use it are businesses. But it's also a family group. Like if you just want to pay for your kids, you give them each an individual email address. And then there's actually two types of groups. There's a managed group where you can actually prepare a restore on your kid's behalf, or on your if you're an IT guy, on your one of your desktop customers' laptops. But if it's an unmanaged group, all you're doing is paying them, and they still have to prepare their own restores. They have perfect privacy, so the product can be used in different ways. But business groups is a free feature. They pay for the underlying stuff. They pay for B1 and B2. The group is just a way to pay for it. Okay, so this going down just a little bit further. I guess there's a This is an example where it says there's one Backblaze account. You can enable B1, you can enable B2, and you can possibly enable groups inside of that one account. You can become a group administrator. You can use any combination of these. We don't care. And we bill you, appropriately for each one. All makes sense? This is all what we do here? Okay. Okay, so this is a breakdown of the sales over time of the different product lines. So the big blue thing at the bottom is what we call B1C. This is the consumer, individual sales, $5 a month, unlimited, and it still results in the bulk of the revenue into this company. This was the original product, so it's been going for 10 years. We think that going forward, B2 will probably eventually take over and become the future of Backblaze. One of the questions always was, in a post-PC world, when no one has a laptop anymore, they only have a phone, and all of their data is in the cloud, where does a laptop backup company end up? And so the answer to that is, we built B2. So when you take a photo on your iPhone, it actually lands on a storage service like B2 called Amazon S3. And it doesn't land on Apple servers. This is just a modern world as you just store your data in one of these service providers like Backblaze in B2. And that's where our world will go, is we are mobile. We do mobile. Mobile is where we're at, but we're not going to do the B1 backup product for mobile. That's sort of the thing that bootstrapped us up, got all the funding, and B1 funded B2. We were able to do B2 without any external funding. We literally built it with the profits from the B1 product line. So you can see the orange is the B1 consumer, but for B1 product line, but for businesses. So a lot of what Morgan focuses on, I assume, is selling into this growing orange area and growing that larger and larger. And B2 in 2017 was $1 million of revenue out of the 22 million. In 2018, I think we expect it to be 4 million. It's 3 or 4 million. So it's literally quadrupling every year. If that rate keeps up, it will eat all the rest of these alive. If it tops out at some point, it'll top out, but my bet is on storage. Okay, and then there's other things like USB restores that we bill for. So you can pay us $189, we'll send you a hard drive anywhere in the world, FedEx overnight. That results in a small amount of revenue to the company, and that's that little yellow mark at the top that's really never going to grow. Yes?
What was the B for B number for last year? Was it 5?
For 2017?
Yeah.
I can get those exact numbers. Wait, do I have them? No, I don't have them. It looks like about 5 million, 4 million, or 5 million
Okay.
is about what it was. And when we say that we think, maybe the laptop backups may pass away in the future, may not, we may not need with all your data being hosted. We have a market penetration of less than half of 1% in the world. So even if people stop storing data on their laptops, all we need is 1% of the people to store data on their laptops, and we're still a useful product for that 1%. And we're one of the last people standing for backup products at this price point. So we're willing to take that business. We could literally grow or double in the B1 product area for 5 years or 10 years. And that's fine. And what we like is this stacked revenue chart. We need all of this revenue now to fund this company. At the end of every year, after we pay all your salaries and we pay for all the storage in the data center, we have approximately $1 left over. So we are profitable, but we love every dollar of revenue. There isn't like, oh, we have to cancel one of these product lines. We literally have to lay off whatever percentage of that, of people, because we just couldn't survive every product line. Okay, and then going on. Okay, so originally, how do we do it? And what the pictures are around us in here are these red storage pods. So originally, we looked into like Amazon. We were going to store all the data on Amazon S3, and they were currently charging. Hold on, I gotta get it through water. They were charging something like, I think, 15 cents a gigabyte, and there was just no way the math made sense. And we added up what it cost to hook up a hard drive, and it was like, 1 penny a gigabyte or something. And we just couldn't figure it out. And there were these other companies out there that would, like EMC, that would sell us storage, but it was also very, very expensive. And one of the market things that people had missed out on, the hardware manufacturers that's now being filled in better, was we needed very reliable storage, but we didn't need it to be that fast. And a lot of data, our data isn't like a database. You don't need really fast access to all the data all the time. You usually back up, and then 2 years from now, you get your laptop stolen and you need to restore. So it's this very slow, we don't need to access all of our data all the time, like sort of a database or really fast. And that market wasn't being serviced very well. So Tim Newfire and a couple of other people built the storage pods. The only thing in the storage pod that is Backblaze is the sheet metal. We basically bent sheet metal in this form factor, and then we bought off-the-shelf components that you could buy at Fry's Electronics and filled it. And the end price was something like 1/50 what you could buy from EMC and things like that. So that made the whole business work. And we came up with a $5 a month price point randomly. We kind of talked to friends, and at $10 a month, some of them would go, yeah, that sounds reasonable. And at $5 a month, people would go, well, that's just a no-brainer. Like, I think that makes sense to me. So we got really lucky. There's a variety of things that weren't brilliant. We just really got lucky. We were able to afford it because of the pods. And $5 a month was a price point people were willing to pay. A lot of people were willing to pay for the service. So these are the very first pods that were ever created. You can see how the faceplate had a different pattern than the modern ones. This one, if you look really, really closely, you can see, I was amazed. I thought we were going to print one of these sheet metal things, and the boards, you have to understand, there are all these screw holes on the motherboards, and I thought there's no way they would get those offsets correct. The first time, I thought for sure something would be off. Everything screwed together on the very first one. I couldn't believe it. But Tim had forgotten to leave a hole for the power button. So they took a screwdriver and we just jammed it in there and bent it aside and broke some of these tabs and then screwed it on. And then they fixed that in Rust too. So, but it was really amazing that a company of 6 people, 7 people at that point, 5 people, 7 people, could actually produce a piece of hardware. It's literally, you just buy these components, you know. It's not completely as straightforward as that. We first tried to connect all the hard drives by USB because it was very inexpensive and we thought it made sense. And the USB spec, you're supposed to be able to plug in like 128 devices. And that's what the spec says. And you could definitely plug in 3 or 4. What you can't do is you can't plug in 45. And we don't know why. When you plug in 45, the USB bus freaks out. I understand if 2 didn't work. But I don't understand how 4 works and 45 doesn't. So we found a different technology, it's called SATA, and it ended up working.
What was the original capacity of the first pod?
I think the first pod was 1 terabyte drives. So it was, and the original pods were 45 drives. Now we're producing 60 drive chassis. These are rows of 15 drives. And originally those were organized into 3 rated arrays, so if you lost 1 drive, you didn't lose data, right? And like on this picture that's up here, this is just an Intel motherboard, a power supply, and we actually had, this was the very first one, we fitted in with 1 power supply. You can buy server power supplies that are super powerful and can power the whole thing, but we actually bought 2 consumer power supplies for like $100 each, instead of 1 server power supply for $1,000. So it was all about cost, but it's not redundant. People saw the 2 power supplies, they might think it's redundant. It's actually, you lose either one and you lose the pod. So pods were still, had a flaw. They were great and they got us bootstrapped up. But they had a flaw in that if 1 pod lost, for instance, a motherboard, you wouldn't lose any data, but you couldn't get it back for some period of time. And for the online backup product, that was actually okay. What would happen when you prepare to restore is it would take, 4 or 5 hours anyway. We'd send you an email when it was ready, and these guys in the data center would run over and try to repair the pod and get it to come back up, and then the restore code would pass back over it, and the restorers would sleep until all the pods were up and stuff like that. But what we realized, what was bantered about for a long time was the concept of a vault. A vault is where you strike the data instead of, I don't know if you guys know about RAID, but instead of striking the data across inside of one machine, where if you lose power to that one machine, you don't have access to the data while it's powered off. We strike any one byte or any one data, we strike it across these 20 machines. It's not important how it works, it's mathematics, it's about this many lines of code. It's not impossible to read or understand, but it's called Reed-Solomon encoding. And you can lose, through this math magic, you can lose any 3 out of the 20 pods. You just dump them in the ocean, and you can still recover 100% of your data back. And it doesn't matter which 3 you lose. That's the cool thing of math. A very simple way to do this would have been to have the data stored in 3 different locations. And then you could lose even more pods, but this way is, we felt the math worked out where we have never, ever, ever had data go down 3. Remember, if you lose 3, you can still get all your data back. To this day, we've never lost 3 pods at the same time. At the very most, we've lost 2 drives in what's called a tome that is striped across these machines. So we haven't even hit the ragged edge yet. When we lose the first drive, and it dies, which happens every day. They replace 15 drives a day in the data center. There are 100,000 drives in the data center, and it's completely calm. Nobody wakes up. In the morning, a computer assigns the task to all the individuals in the data center that go to, data center 4, go to row 6, go down the hall, go to this pod, pull it out, replace the drive. That's totally calm. When they lose 2, though, in the same tool, people start waking up, people start driving toward the data center, it gets more exciting, and as I said, we've never lost 3, but we can lose 3. And then, 4, we actually suffer data loss. So we don't ever get there. Okay, so after all of that, we are almost, Ken isn't here. We as of sometime in January, we're gonna migrate the last of the B1 consumer data off of the original pods into vaults. So to this day, a little bit of data is still left over in the old system where it's a single point of failure, where if that pod is offline, you can't get the data back. If you're using the B2 product line, 100% of that has always been on vaults because of the availability thing. You want to use it to serve up data on the web, other stuff like that. We want it to be very, very highly available. But B1 still has data stored in individual pods in the data center. The last of those leaves this company in January sometime, and we're going to have a celebration. Okay, so the rest of this talk is about the B1 client and how it works. So if you have questions about B2, we can talk about that later, or the account login or anything, but the B1 client is very, very, very simple, okay? And this is the B1 client backup flow. What happens is, a client, step number 1, a laptop in the world wakes up once an hour and it says, I need somewhere to store my data. So it calls home to what we call the cluster authority, CA001. And it asks CA001, can you tell me somewhere in the world that I can store data onto the pods? And it assigns it a pod somewhere, a vault. And then the client, the laptop, hangs up and doesn't bother the CA again. It then contacts that pod directly. Because we invented this ourselves and we own both ends of the protocol, we wanted it to be cheap, so we never bought any load balancers. It doesn't have any choke points in the system, and it turns out it's very inexpensive. And it scales really well. We have 500,000 individual laptops backing up into our data center, and they have to call home and get the location of where there's free space in the data center. But other than that, it doesn't have to do anymore. The clusters, then, you are bound. That's another unit of scale for our company. The clusters, the CA0, we have 3 clusters in the world right now: 000, 001, 002. Your account is bound to a cluster for life. It cannot move, it cannot migrate. Clusters are also regions. So when we open up Europe, either later this year or early next year, that will be in a new cluster, 003, something like that. And your account is bound there, your data is bound there for life. It can't move between clusters. This means we have to stop putting people on a cluster when it starts to get loaded down and overloaded. And one of the problems at Backblaze that keeps coming up is CA001 kicked butt for us. It did great. It took something like 300,000 customers, but it got overloaded. We didn't get off soon enough. And so it's constantly struggling to keep up. But if you create a new account, we put it on 002, it's unloaded right now. And the cluster, we have 3 digits, and we have plenty of space, and I've had to go through several times proving to people that this can go forever. There's no limits to the scaling. If you think we're going to run out at 999 data centers, you're wrong. We actually can use letters for the cluster authority. So it's not just 000 through 999, it's alphanumeric. You can go C, A, B, C. So we actually could keep going for decades this way. Okay, so the first step is to ask where in the world I can store some data. And then the laptop backs up data to that laptop, to that vault for as long as it wants, until either one, the vault crashes or goes offline, or the vault fills up. Same thing. The vault can just hang up on a client, and then it's very profoundly fault tolerant. The client then goes, oh, I've lost my connection. I can't communicate to my pod anymore. So it has to go back to the cluster authority and ask for a new pod. And that's how the system works. And so whenever a vault crashes or goes offline, or the guys in the data center just take it offline because they want to repair something in it, that's fine. The clients just bounce to a new location and start backing up data somewhere else in the data center. And then when the client is all done backing up and it's finished, the design of it was laptop CPU time and laptop I/O is all free to Backblaze. So we pushed off a lot of the intelligence, probably a little too much of the intelligence. We pushed off into the customer's laptop because that was absolutely free for us. We didn't have to scale that. We had plenty of them, and you pay for the electricity. So at the end, the laptop has to go back to the CA and tell it where all the files are that it pushed. So there's and we'll get to that how that works in the next. But the first step is to ask where it should back up, and then it backs up. And the only person in the world that knows where all that happened, most of this data center is stateless, was the client. And then at the end, the client uploads the list of where the files are to the cluster authority, and that's the last step. Okay, so the final part of this talk, which can go on for a very long time, is a description of the BZ Done format. I'm going to try and get this all on one slide. Okay. The top is my quote: "Understand BZ Done files and you understand Backblaze." That's no longer the case now that we have the B2 product line, but in the old days, this was totally true. Okay, so I did not have the brain power or the designer to do anything complicated. So every idea here is, this is the world's most simple format, and it's a log-based format. We never lose any information of anything that occurred in your backup ever. And what happens is, if you look at the very first line on this slide of what's called the BZ Done file, and why it's called a BZ Done file is, the first step that the client goes through is it comes up with a to-do list of all the files it's going to back up. And then when it's finished, I called it a done list because I'm an idiot, and done had the same number of letters as to do, and that made all the files line up in my browser. Anyway, the point is, it's too late. That's why they're called done lists. This is what the laptop has done is represented in here. And it's an append-only format. In other words, you never ever delete a line. It's illegal for these to shrink. They will never shrink. Anything that occurs is recorded in this history of events. And that's just been really valuable for us to figure out what went wrong. For instance, when you say, well, I didn't delete that file, then we can point to the exact moment the laptop decided to delete the file. And if it was 4 years ago, if it was 10 years ago, if it's 30 years ago, it's still going to be in there. So whenever we dive in, it's just been really nice to have that complete history. There are some side effects of having the complete history, which is as your backup gets older and older, it slows down. And there's one of these BZ Done files for every day that your backup ran. And so for the first year, that means you only have 350 files. And 350 files is totally doable by any modern laptop computer on an SSD. In your 10th year, that's 3,500 files. And that started to slow down. And so what we recommend is that you uninstall, reinstall, and repush from scratch whenever you want your backup to speed up again. Now, and originally when I built this, I went, shoot, if we're in business in 3 years, I'll be lucky. This will totally scale to 1,000 files, 3 years, and it'll all be fine. Well, we've got backups now that are like 11 years old, and it's getting kind of slow, but it still works. There's nothing wrong with it, and we have people with 100 million files in this system. But here's how it works. The very first line you can see up here there's this first column. Says column 0, and there's a description of each of the columns below in this. It's on Whistler, and I can also talk anybody who's interested in it through it. The first column is 5, which means the line version number. It's how we're going to parse the rest of the line. 5 means we screwed this up 4 times, but this one's final. And this slide, I think, was done in 2014. We haven't changed from line version 5. We finally got it right. It's beautiful. It's perfect. It'll never change. Okay. So that'll you'll see nothing but fives your whole career here. Okay, column number 1, the very first file is if you decide to push a file. Now the file name that you've decided to push into the data center is on the far right column. It says column 13 is the file name. This file format is absolutely one of the reasons it's so fast and so much faster than most other systems is there's absolutely no encoding allowed. So this is UTF-8, but all of the columns except for the very last column would work in US ASCII. And then the very last column is UTF-8, so it has to work with Japanese and French and everything else, and it does. And the only rules are it starts with column 13, everything up to that point is well known, and then those are raw UTF-8 bytes. And then they end with a carriage return, a \n. And you're not allowed to encode a \n in a file name in our system. The Mac, in all their brilliant wisdom, allowed that to occur, but we actually just pack it with our own little method, and we don't allow it. So it's very, very simple. It's very, very fast. There's no decoding. You don't have to JSON encode it. You don't have to XML encode it. You don't have to HTML encode it. It's just raw bytes. Okay, so this is a plus sign in column 1 means that we're adding a file to the backup. A minus sign in column 1 means that that file has disappeared from your laptop. But a minus sign does not mean we purge it from the data center. An X line means we've now purged that file from the data center. So what normally happens is a file is added, that's a plus. Sometime later, you delete that file from your laptop, that'll be a minus. And 30 days later, an X will appear when it is purged from the data center. If the X isn't in this file, it's still in the data center. And hello? All right. Anyway, so that's that. In column 1, then, there are a couple more interesting characters. That is the way we think about the whole system. Plus, minus, and X. That's all we think of. The details are a little more subtle, and one of the details is the equals sign. So an equals is a deduplication. If you have the same file contents twice on your laptop, we dedupe. I had to build this in right at the beginning of the client because I didn't know how to handle when you'd moved a folder. And so if you just rename a folder, Backblaze, the program, the backup program, the client on your laptop, wakes up and it profoundly has no idea that you renamed that folder. And what it does is it says, oh my gosh, you've deleted a bunch of files from the old folder location, and it issues a bunch of minuses. And then it says, oh, I've got a new folder here I've never seen before, and it issues a bunch of pluses for the new files. But instead of doing pluses, it's able to do an equal sign, which is a deduplication. And it doesn't have to transmit it into the data center again. It just uses what's called column 4, and we'll go into column 4 in great detail here in a second. Column 4 is the file ID that completely identifies in the data center where that file is, where it lives. So the equal sign utilizes column 4. So going back to line 1, when we pushed into the data center, it's a plus sign. The column 3 is the date. There's a few flags in column 2. I'm just going to skip over for a second. Column 3 is the date time that this was issued on the laptop. So this is when the event occurred. Now, the earlier file formats that I screwed up, I tried to combine some of these columns together, and it just ended up being a debacle. And really complicated. So the column 3 is very, very simple. It'll always sort of be monotonically increasing. It's in GMT. It's in London UTC time, and it's when the event occurred, when this line was added to this file. The next line, column 4, is where all the magic is. And this has a 4 underbar at the start of it. This is an ID of where it is in the world, where the file is stored. And I can point to the exact pod it's stored on based on this ID. And there's no redirection, and it's totally simple because we didn't have time to build anything complicated. The number 4 means we screwed it up 3 times. So this is the 4th version of this ID. So the 4 underbar, and then there's an H. This is the host globally unique identifier. It's called an HGOOD at our company. In B2, it became a bucket ID. It's 24 characters long, it's hexadecimal, and it uniquely identifies your backup in the whole world. But that's not where it is in the data center, but this identifies who owns this file in the data center. Then there's an underbar and an F. There's a 16 digits here of hexadecimal. You'll see zeros in almost all of them always, because this is a monotonically increasing file ID that we use to make sure it's different from all the other ones. Then there's the day, minutes, and seconds. So if you see the D, it says D, and then 2014 was the year, 05 is the month, 10 is the day, and then underbar minutes is hours, minutes, and seconds. That this file of when the file landed in the data center. So when I said earlier that I confused the columns earlier, I tried to save some space by combining column 3 and that column, but it's a mistake, because when you dedupe, the time that you had the dedupe line is radically different than the time that it was put in the data center. You dedupe years later against a file that was pushed earlier. And so that's why I started by combining those, and that was a total screw up, and it was hard to understand the code and everything, and now it's all sorted out. So this just refers to the when this exact data was pushed into the data center, not the particular line anymore. Okay, so hours, minutes, and seconds that was pushed, and then here is where the magic of where it is in the data center. C001 means it's on cluster 1. And so the C001, since users can never move between clusters, this C001 will be that way in every line of every busy done file. And that sounds wasteful, but and that's why, again, I screwed up earlier and didn't do that. But it just turns out that every once in a while, some crazy user will actually copy some of the lines from one of their users and paste them into a different file. And that is a debacle. This is I have this idea of doing this blog post on paranoid programming. You think that your world operates on a certain number of rules, then you find out that the laptops have bad RAM in them. Or a user is just batshit insane and has decided, they go, no, I figured out your file format. I don't have to repush my files. I'll copy and paste these lines over into this other client. And it's like, that didn't push the files. That just profoundly lost the files, so this is the kind of thing. So anyway, this C001 is the cluster you're in. V is the vault that it's on. So this is vault 645. T is the tome, which is a tome is a group. 20 drives, 20 drives in 20 separate machines, and then so it's a CVT, cluster, vault, tome, and that'll identify exactly where your data is in the data center, in one of the data centers worldwide, and these are completely worldwide file IDs. We can just look through it, and everything's great. Column 5, uploaded member pod. It turns out the client talks to one of the 20 pods in the vault and uploads the file. This just happened to record which member pod it uploaded to. I didn't know if it was going to be important or not. Now we have it. Now that's where it was. It can also help debug problems in the future. If there was one bad pod that had bad RAM in it or something like that, it would help explain what was going on. You can also do statistical analysis about whether pods have been talked to more than other pods. Column 6 is very, very important. It's the unique identifier of column 13. So column 13 is the file name on your laptop. We don't know your file names. They're absolutely encrypted, and we're not allowed to know them. So we assign every one of the files on your laptop a unique monotonically increasing number, which is stored in column 6. It identifies the file name. If you rename a file, it gets a new name. And this is also how we do the 30-day rollback history. Any file name if you assign a file like c:\dog.jpg, you assign that file ID 3. It's got to be 3 for the rest of time. So you can delete that file, wait 4 years, and then recreate a new dog.jpg in that same spot. It's got to get that same file ID back. And that allows us to do the 30-day rollback history. We can say, oh my gosh, without knowing the file names. Oh my gosh, this file ID was created at this time, and this file ID got a minus sign later. But we don't actually know your file name, if that made any sense. So Okay, and then column 7 is some internal stuff I'll get to in a second. SHA-1. Column 8 is the SHA-1. So SHA-1 is a checksum. It helps us verify that the contents of the data. This is the SHA-1 of the original file, and this is how we do deduplication. A SHA-1 is basically you run all of the bytes in a file through this algorithm, and it comes up with a unique number. And SHA-1s are very, very unique. They're not infinitely unique, and so there could be. It's theoretically possible to have collisions. That's why we don't dedupe in this system. We don't dedupe across between accounts. We only dedupe inside of your one laptop, and so that reduces the chance. We've actually never seen a collision, and it would be very difficult to have a collision. But anyway, column 9 and 10 are the creation time of the file on your laptop and the last modified time on your laptop. People really, we use the last modified time to know when a file has changed. So we rerun through these files when we're going to do a backup, and we say, oh, this file, dog, had a mod time that has now changed, and therefore we will go ahead and look at the contents and see if we want to back it up. We also use it when we restore. A lot of people think of the last mod time or the creation time as very important information. Like when you restore all your photos, some photo organization apps organize them by time. Most photo organization apps organize them by creation time. And for instance, all of your wedding photos were taken on the same day, so we can group those together and know what's going on. But if we lost that information, then you couldn't restore the data fully. So this is envelope information outside of the file. And then the file name, as I talked about. Okay, the last little subtlety that I want to talk about today, and then I'm almost done, is large files. So we originally, any file that's a plus and a minus and just has a dog at the end or cat, any file that is less than 30 megabytes, we just push as an entire file. Any deltas, we just push a whole new file. There's no sub deltas, there's no sub diffing between them, and there are no parts to that file. That's a simple file. That's a small file, what we call a small file. Any file larger than 30 megabytes on your laptop, we break into 10 megabyte chunks. And we did this for a variety of reasons. We wanted a size that we could successfully transmit over the internet in 2007 and be sure that it would complete on relatively slow internet connections. We can't, and I've been asked by other people that have done backup clients. They're like, "Why'd you pick 10?" And I'm like, "I don't know. I just pulled it out of the air. I have no idea why I picked it." And I'm like, "What did you pick?" And they went, "I picked 5, but I don't know why either." So none of us know what we're doing. 10 is a perfectly reasonable chunk. What we have over the years, what we have seen is HTTPS is there's a certain amount of overhead with negotiating the connection before we can push it over the internet. There's also this thing this completely depraved and evil thing called TCP slow start, which the internet guys think is great because it's protecting the internet, but it means that until a file transmits at least 40 megabytes, you're not getting the full transmission speed. So if you're in Australia, you start transmitting very, very slowly, and you wait till you get the acknowledgments, and you start speeding up, and you see that everything's going well, and about 40 megabytes in, you're getting the full transmission speed. So the 10 megabyte files is not quite big enough, but it's not going to change now. But I did reserve some space in this file format. In column 7, it's a 0 if it's a self-contained file, and it's a 5 if it's 10 megabytes. Those are the only two values. But I reserved 1, 2, 3, 4 for less than 10 megabytes, which we're never going to do because that would be a mistake. But I reserved 6, 7, 8, 9 for larger than 10 megabytes. So we could move to a larger file chunk size. It would just be a lot of code, and it would be a lot of differences and stuff. So because 10 megabytes is not large enough to get the maximum transmission speed on the internet from Australia or New Zealand, we added threading to the client. So you can run up to 20 individual threads. So this is why TCP slow start offends me. Everyone in the world knows there's this problem. So instead of making each thread faster like they should have, everyone adds multiple threads. But that's just stupid. Like, why you're talking from Australia all the way to a server in Sacramento, and you have one thread, and your bandwidth that you have is 10 megabytes or 100 megabits or a gigabit, and we have a gigabit, but you need 10 threads to take advantage of that. And that just doesn't make any sense to me. It just seems like you should be able to get the maximum throughput from one thread. And in other news, we've never seen an internet thread go faster than a gigabit, and we don't know why. One thread cannot go past a gigabit on the internet. So if you want to get 100 gigabit transmission speed, you have to go to multiple threads. And we don't know why. I don't know why. No one knows why. No one that I've talked to knows why. So anyway, so what we were talking about is large files. So large files have they push a bunch of plus signs for every one of the chunks of the large file, which are in column 7 are fives. K5s means that it's a chunk size of 10 megabytes. Each one of those has the same file name at the end here, you'll see. And column 12 is actually the number of bytes in the file. In a previous company, we kept getting bitten by bytes versus megabytes versus kilobytes and the round off errors, and everyone argued about it. So I made sure all these file formats were in a raw number of bytes so that you couldn't argue. I don't have any religion around it. It's just, so this is a 234 byte file is in column 12 here at the top. And that's the dog.jpg. Okay, so there's an extra couple of columns on files that are large files that have a CF, and that's a chunk file ID for each of the chunks inside of this file called pig. Each one of the chunks will be the same size except for the last chunk. Okay, so what happens in a large file if you change something inside of it? Well, the worst thing you could possibly do to our system is prepend 1 byte to the file, because we will, by definition, we can't dedupe. We dedupe on the 10 megabyte boundaries, period. And we can dedupe between files with different 10 megabyte chunks. We can dedupe any chunks against standalone files, but the point is that we deduping, and the chunks are all 10 megabytes. So if you inserted a byte at the start, it would shift the file down and it would destroy the whole file. You have to retransmit the whole file because it's all different now. The best thing you can do is append 1 byte to the end of a file, because if you append a byte to the end of the file, only the last chunk changes. We only have to transmit the last chunk of the file. And then there's an exclamation point in line column 1 here, which means that's the meta line that summarizes everything about that large file. So in the case of this pig here, the file name pig, it transmitted 1, 2, 3, 4, 5 chunks of pig. Then it listed this summary line with an exclamation point. And there are a couple of things about that line that are unique and you'll find interesting. There is no data center location in that set of columns. You notice the dashes here under F and D and M. That's because a meta line doesn't exist in the data center. It's just a summary of the total file, the size of that file, who happens to be pig in this case. And then the chunks are each given a monotonically increasing number in column 7. You can see it's K5N000, 001, 002, 03, 04, 05. So the other reason to pick a slightly larger chunk size would be it lowers the number of chunks, which lowers the size of the data structures, that we have to maintain for various things. But anyway, 10 megabytes is actually taking care of us as a company. It's been a very reasonable trade-off. The slowest dial-up modems can manage to get 10 megabytes transmitted in a reasonable amount of time, let's say a couple hours. And the fastest, machines that are pretty close to our data center can get pretty high bandwidth out of that. People can use it. Basically, worldwide, you can exceed any upstream consumer bandwidth right now. So as long as you don't have Google Fiber, the client is not your bottleneck. It's going to be your disk or your bandwidth or something like that, which is the bottleneck in the client. We can easily exceed like 50 megabits up, and most consumer bandwidth, even 12 years later after we founded the company, 20 megabits up is a really good, United States ISP bandwidth. Morgan. Morgan is asking, why is the backup fast, or why is it perceived that way? There's 2 or 3 or 4 parts of that. One is the client was absolutely designed to survive and be reasonably lightweight and run in the background. It was designed to run in the background and never be uninstalled and just run constantly in continuously mode. And that was its forte. And so it was designed for 5,400 RPM drives in laptops in 2007, which is what I owned. Modern hard drives are 7,200 RPM, and most people have moved over to SSDs and laptops. And so it's lightweight and doesn't bother you because it's still running designed for this slower set of machines. And one of the reasons it's lightweight is because it runs slower. It's not just about the CPU load. When we index the drive, we're not CPU bound at all, but what we do is the process that indexes the drive is called BZ file list. It actually just sleeps every few seconds for like 4 or 5 seconds to allow other crap in your system to do stuff and to not create a bad load on your drive. So it's all designed to be lightweight. The faster side of it, a lot of these backup software that build for $5 a month unlimited, or $6 or $7 a month unlimited, they didn't want it to go fast because, and the most famous cases like Carbonite, they backed up your first 50 megabytes or 50 gig very, very quickly, and then they slowed it down, called throttling. It was brilliant, really. So they said that they had unlimited storage that you were allowed to store, but you could never get 2 terabytes uploaded because it would take 5, 6, 7 years. So, and it was all artificial, and they got sued for it, and they had to stop doing that. So they got sued for false advertising or whatever. But it was actually a kind of a brilliant way to counteract. My dad was always stressed that he might add a byte and he'd get billed for it. And that, but it was a way of discouraging the pigs from using your system. Was they couldn't use it because it was fast. Early on, there were a few reviewers who, instead of evaluating the product like I liked, which is, once the initial backup is over and once it's in steady state, how much does it load your computer and does it stay up to date? That's how I think you should evaluate a backup software. The reviewers would install different backup software and measure how fast and how much they could saturate your bandwidth and overload your hard drive. And they claimed that the more it was overloading your bandwidth in your hard drive, the better the backup product was. And I thought that was silly, but it was one of the things that reviewers did. And so over time, we took the risk and we went ahead and added threads and we made it fast, and we hoped that it wasn't going to be a mistake. And it allowed, by default, we use 4 threads, and it's a really reasonable default for most people that does really, really well. And if they go in and customize it, they can go as high as 20 threads. And we might even increase that for January to 30 threads because it doesn't really hurt us. People are getting fully backed up. We're not defeating anyone by keeping the thread count low, and it's a way of getting making even more people happy and getting better reviews and stuff. But I don't know why it's fast and lightweight. I think some of the decisions we made. Oh, we also batch small files together. So because there's this fixed overhead with setting up an HTTPS connection, when you when we first launched the product, when you transmitted a 1 byte file, you would set up this entire connection to the data center. You would send 1 byte, and then you would tear it down. And that means that small files would get very low throughput compared to larger files. And so the first thing we added before we added threading is we added batching, where we batched up to 999 small files together to get the performance up. So I think there's a variety of things. I think the language it's written in is also an efficient language. It's C. It's a dead language, and you'd probably never do it again in this format. But it is fast. And there are other things that we could do even faster. Every once in a while, like a network engineer will look at the protocol and decide that we could be 3% faster if we did something differently. And I always go like, I'll get right on that. Like what am I working on this week? Single sign-on. We work on installers and downloaders and iOS clients. We can't spend all of our time working on the performance aspect of it. But I do like the fact that it's efficient and it's lightweight, and I still run the actual product. So I still like it enough to run it. So, and that's exactly an hour. How was it? Any other questions that people have? I'm here all week. Morgan. Yeah. Okay, in B2, it is absolutely not a problem because B2 is a completely, we charge for the number of bytes stored. So that's one of the reasons we also love B2. Also, hard drives are getting cheaper by 1% every month. And this has been true over almost our entire history. So our costs go down by 1%. Now, in the B1 product, people store 2% more data every month than they did before. So our margin is eroding by 1% a month, 12% a year. Now we've had other efficiencies. We've gotten cheaper data centers. We've learned better dedupe technology. We have better dedupe technology. So we fought that fight as long as we could, and we're going to lose it in February 2nd of 2019. We're going to raise prices of B1 by $1 by 20%, which will buy us 2 more years of margin, and the products essentially are 50% margin. So, which is about where we want them to be. We can't go much lower than that. When I say 50% margin, the cost of goods sold, COGS is what the industry calls it. The cost of goods sold includes the electricity in the data center, the hard drives in the data center, the employees in the data center salaries is all part of what we consider the cost of goods sold. The margin is what we pay my salary out of. So it's not that it's just free money, it's still necessary. It's what we pay the developers, because the developers are considered a one-time cost. Once they finish developing, they're done. Realistically, we know that yeah, AB is laughing in the back. So realistically, we all know as developers that you have to maintain the stuff, you have to chase the OS developers like we're doing with Mojave this week. So whether or not that's an honest calculation, that's the way it's done in the industry. So it's 50%, but we still spend 100% of the 50%. So we can't really go much below a 50% margin. But yeah, so it is a problem that that people are storing more data every month, and we just have to watch that and figure it out.
Brian, could you repeat the questions, please?
Oh, what was the question? I'm supposed to repeat the question. Oh, storage was outgrowing sales, and so the question was that a problem? And the reason storage is outgrowing sales, there's two. The answer was just twofold. People are storing more data, and that's a problem for B1, but it's not a problem for B2 at all. And it won't outpace sales when it's 1-to-1. When it's all B2 sales, then it would match. But it's not a problem because we actually storage gets less expensive. That's part of that curve of why storage is growing faster, but our sales is going flat. Is storage is literally getting less expensive. Oh, while we have price increases for B1 planned, we have price decreases for B2 in the budgets, in the plan in the future. So every year around June or something, we're going to drop the price of B2 from now on to match, So these two product lines, B1 and B2, actually make the same margin. We're at this point, we're completely agnostic where our revenue comes from. People think that we're on the internet. Sometimes people think we're pushing them toward B2, and they perceive B1 like a guy will have 4. The break-even point right now is 1 terabyte. If you have 1 terabyte of data, you can use B1 or B2, and it costs you the same thing, $5 a month. But people with 4 terabytes will show up and go, "You're trying to push me into B2." That's your plan all along, and it's really not true. We don't really care which one you're in. It's just that B2 has a lot more customization. They'll say, "I want a bigger rollback history, and I want B1," and it's like, yeah, for $5 a month, you don't get any customization. So stuff like that. Very good question. Okay, so the question was, when this BZDone file is sent to the CA, but we also made the claim that we don't know the file names. So there's what we do is we split this file into 2 halves. We split it into everything before column, I think column 9 or something. Even the file mod times and file create times we don't know. And everything to the right, 9 and to the right, is encrypted with the same encryption that your files are. And so if you set a private encryption key, we literally can't decode it. We have no idea what it is. Now, all the other columns are actually uploaded just compressed. It's text. So simple zip compression gives us 10-to-1 compression in the CAs. We have to buy less disks. And it's little, I don't know if it's a good idea or not, but it's 1/10 the amount of disks that we have to buy. So because of that, there were 2 halves, and for a while, these were 2 separate files in the data center. And then, if you ever hear us talk at this company about the BZ COMB files, COMB, that's because because we combined them back together again. So actually, the plain text half and the encrypted half are bundled into one bundled file in the data center. We can only read half of it without your password, and we read the other half of it with your password or with your private encryption key. And And the reason we combined them was for I/O reasons. Running across all of the files to back them up onto a separate server was twice as many IOPS if we didn't have them combined into one. And they really are the same file. One of them doesn't make sense without the other one. And so, and the reason it's COMB, and I'm emphasizing this for the reason of the screw up that happened. COMB is the same number of letters as to do and done. So all of these files, we just never wanted to change the length of the file name, and we wanted to combine them together, and so now they're COM files. But a BZ-done file and a COM file, we just think of them as the same thing. One of them you can read, the BZ-done file you can read without your password, and that exists on the client's laptop. On every one of your laptops, you can go in and read these files of what's happened. And then in the data center, the file names are all encrypted until when you go to browse the tree. And then when you go to prepare restore in B1, what you're literally browsing in the tree browsing view is this file. This is what you're browsing. So you can look at your laptop and see what you would have, seen in the tree browsing server, or you can go into the tree browsing server and log in and see it. It's the same thing. It's just browsing these files. That's what it's doing. It's very, very simple. Anything else? All right. Did the camera die? I'm hoping the camera died. It usually makes about an hour on the battery. Is it still alive? It's all right. The end Q&A probably is cut off. Anything else? Anything else? All right. So this is a lot of information about B1, and most of you don't care. And that's fine. As if you do have, like, the support people care because they have to dig into these, and some of the engineers care, and as you continue on, you want to know more information, we can dig into more. There is some subtlety to these file formats in how you interpret them and how you reassemble files, large files, how it takes to reassemble them and stuff like that. So and then some of you I've seen now 4 times in this presentation. It just repeat it. Nothing. No one can get all of this in one shot, and so just watch it over and over again. All right. Thank you, everyone. And then this is we're all done for the remote people, but we're the normal thing to follow this on is then how does B2 work? And that's what the talk that AB could give at some other time. But B2 retain the same one account login, but instead of having BZ-done files, they have the Cassandra database. So one of the flaws of the BZ-done, which is really, 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 really profound, is if you just wanted to identify one file, you literally have to look through all the BZ-dones for it. It's not indexed on a file name basis. So you just have to do a flat list through, and it could be 100 million lines if you have 100 million files. So Cassandra, is much, much, much more expensive than this, but it has these advantages, which is you can look up an individual named file, but that's not, it's a different application. And the other advantage of Cassandra is when the cluster authority is down, like during the weekly push, you can't do a restore. And Cassandra, for those of you who, it's better if AB gives the talk, but Cassandra is this cool database where there are, do you have any idea how many nodes were? So we have 21 individual 1U servers with all the data kind of spread around, where much like our vaults, you can lose any 1 or 2, I don't know what the redundancy is on those things, you can lose 1 or 2 of the Cassandra nodes, and the database is entirely still up and fine, and you can read all the data out of it. So the CA is still a single point. When you lose the power supply in the CA or whatever, then it's down and you have to repair it, or you lose the file system. But Cassandra's cool. It stays up much higher, but it's a little more expensive because you got to buy more nodes. I think B2 on that cluster is something like 10% of the data in the cluster. So the 20 nodes, if you filled a cluster with 100% B2 data, it would need something like 200 Cassandra nodes in order to run. But we have, Elliot convinced me that this is not only plausible, this has been done at other companies, that Cassandra scales up that big. And so one of the ideas of the cluster architecture is the cluster has to be built to scale to a certain size. then you stamp out more clusters. And that's how we scale. And we believe we have sort of solved that problem. That will just keep stamping out clusters forever. We don't have to worry about that. We are having, like, in B2, a few customers have more than 1 billion files in a bucket. And it's working. But Cassandra, the design, we have to like tweak that up a little. So there is scale work to do left at Backblaze, but we believe it's mostly solved. There used to be a day where the cluster authority would, when we only had one, would fall over, and we were just up all night trying to get more performance out of the system and re-optimizing, and it was painful, and everyone just hated, the fact that if we were successful and a bunch of people signed up, we would also go out of business. And so we have a joke at Backblaze where we would say, but luckily we never grew that fast. But it's also unfortunate that we never grew that fast. So we think we're ahead of all of these problems, and we're really in a good place right now where we can stamp out more of these things. The other weird thing about our business that I'm fascinated by was when we only had 1,000 customers, we grew by 20 or 30% a year. And so 1,000 customers became 1,200 customers. And that was really sad. It was really slow. And we could only hire, one more person a year when you can grow the company by 20%. Well, when there's 10 people in the company, that's 2 guys a year. So early on, a lot of the growth, all these people that you see around here, all came in when did you start? 3 months ago. So all this growth really picks up. And what I don't understand is, where were all these customers earlier? Like, it's the same product essentially. I mean, B2 is a different product, and that we couldn't have had the B2 business. But B1, look at B1. We've had the same product for all these years, and from a customer perspective, I mean, we had to grow it internally, and we added a few features. But let's say there's 45 million customers that would benefit in the world, that would benefit from this product. Why can't I have those all tomorrow? Why do I have to wait? But for some reason, it's like the product is ever so slightly viral. It's like 20% viral. Like, everyone tells all their friends about it like once every 5 years or something like that. So I don't know. I find it really interesting. Like, where is that 50% growth going to come from next year when it's more money than we've ever made? But it just keeps coming like that. It just keeps, unloading on us at about between 20%. Our worst year ever was like 20% growth, and our best year was like 50% growth. So anyway, all right. Thank you, everyone. Thank you, remote people.